Ladies and gentlemen, welcome back to Amateur Repair Time. I have been working on this cool Westinghouse radio here. And in the previous video, we looked it over a little bit, did some caps. And today, we're going to do some resistors. And then try to power it up, maybe. Work through it a little bit, see what we can get done. So, here's our cap job. Now, you know, this is amateur repair time, people. So we've got several here. This one is a strange one. You wouldn't think there would be an electrolytic there, but there is. Let me see if I can find it on the schematics again. Somewhere in here, there was a fairly large electrolytic. Well, not fairly large, but compared to the other ones, right? So it's a 4 microfarad electrolytic right here on the FM detector. Now, I haven't done many FM radios at all, and I think this may be the first tube FM radio that I've done. It's an AM FM. But there was an electrolytic right there. So that's that one that you're seeing. I was able to mount it without any kind of, I didn't have to add in what do they call them? The little bars that have the connectors on them. I didn't have to add that in because I was able to mount it directly on the tube socket and ground, right? So what I've been doing is cutting off the old one and then J-hooking the new one in. And I mentioned on the previous video how when I first started, I didn't do that. I would completely remove the end where it was soldered to everything. But I started noticing when you do that, you kind of sizzle it a little bit, you know. So if this is an old Bakelite socket or whatever this is made out of, if I start going hot as hell on that pin there to get that little piece of the end of the cap out, you know, you're unnecessarily heating that up, and it could cause problems down the road. So it's much easier to just leave a little bit of the trace of the cap leg on, or even leave all of the cap leg on, so it gives you plenty of room to bend it over, and then bend your new one through it and solder it together. It doesn't look quite as pretty, but I think you get a better product at the end because you're not burning up all of the connections everywhere where you remove the old cap. Shango talked about that. That's the first person I saw talking about doing it that way, and I think he's got a damn good point. Now, so I went through and replaced them. I've also been checking the resistors as I went through, and a bunch of them are out of spec. Usually when I do these, 2 or 3 of them are a little off, right, or bad enough to worry about. But in this case, there's a bunch of them. There's probably 10 or 12 of them that aren't right, so we're going to replace a bunch of those too. Which I hate that we're going to have all new stuff under here, but we just have to, right? So the electrolytic was a big can down here, the filter, and it's 60 and 80. I went with 100 and 100, and I think that'll be fine. I don't think that's a problem. So the can was right here. One of them, you know, of course, they're from ground to whatever the lead is. So one of the lead comes off the selenium rectifier that's mounted up on the top, comes down in here. So we've got an axial here from here to here. Now it's 160 volt. It would be better if I was 200 volt, but I had 160 volt. The B plus is supposed to be 149 volts. So you're right there at it, especially since the line voltage is bumped up now. And then also, we're going to test it with that selenium rectifier in it, but the way those things fail usually is they raise the voltage. The voltage gets too high on them. But we'll figure all that out. We're going to have to replace that with a diode and a resistor anyway. So we got that one in. And then the other filter cap, there is a line that runs from here that ran down to the filter and then ran from there over to here. But I was able to just mount that one on the support that's already here. Positive there, negative there. And it is a 250 because I could do that with the radial pretty easily. I could do this one with the radial too, but it's going to be all right, folks. All right, so we got that. And so, like I said, I worked through, put them, replaced them, and put them in. And then I got over here, and there were these weird ones that went actually through this plate But once I'm, you know, got them all out, I was able to figure it out. And so there's some down here that go to ground and stuff. And then there was a couple here that go up to this terminal strip. I guess that's what they're called, right? And over to here. These things appear to be, you know, that looks to me like that's a resistor that's like 12 ohms. But there's nothing in the schematic like that. So I think those may actually be considered coils. You know, they look like a resistor and they're marked like a resistor. They measure less than 1 ohm resistance, all of them. So that's some kind of coil actually. So for instance, you can see one is coming right off of the oscillator, right? It's connected to one end of the oscillator. Well, if you look at the schematics, here's the oscillator. There is a coil coming right off of it. So I think that's it. So let me see. It goes between that and... So I'm looking here. It goes between that and the 12BE6. 12BE6. Yeah, so see, it goes between that and the 12BE6. There is a coil. I would call that a coil. Maybe it's considered a choke or something. I don't know. But that's what those are. So they're small, right? But there's several of them. There's 3 or 4 of them. But if you look on the schematics, there are several of these, what I'm calling coils too. There's another one. They're all over the place. So I haven't noticed that before either. But, you know, like I said, I've been working through and checking all the resistors as I went. So next thing we need to do is replace those resistors that are measuring bad. So I'm going to make a whole list of them. See what I can get my little paws on. Here's a, you know, from the schematics, there's a list too. And then go through and replace the ones that are wildly out of spec. And some of them are. Like this beefy one here at the beginning is supposed to be 22, but it's 60. You know, that's a little high. If it would stay 60, we could leave it like that because the voltage coming in is going to be too high as well, right? So all it would do is lower it. But, you know, it's fatigued basically, and it's taking in water or whatever they do where these carbon ones go up in value. So it's not going to stay like that. It's going to get worse and worse and worse. So you got to replace it. You can't just leave it in, even though it's a slight alteration on the design that you maybe prefer, because it's going to help us get this voltage down here, right? But we'll see. And then, of course, like I said, we've got the selenium rectifier we're going to have to get rid of. I think I'm going to power it up with it, though, at first, just to see what we got going on. So once we do the resistors, what I would like to do is, I was going to say I'd like to, well, yeah, that won't work. I was going to say I'd like to fire it up with just the rectifier tube in it, but it doesn't have a rectifier tube because it's got the selenium rectifier. I guess you could fire it up without any of the tubes in. I'm not positive that that you can do that. I think you can. But we could create a situation where without a load it burns up some resistors. I don't think it would, though. And you know, we've already got that B+ voltage on the output transformer anyway. I think it would be all right because we don't have anything that goes above that, do we? We're not going to have a load, but we're also not going to have any voltages up over that. Let's see, will that work? I think that'll work. Yeah, I think we can just leave the tubes out, power it up slowly on the variac and the ammeter, and see what that selenium rectifier is doing. Just for giggles. I mean, we're going to replace it, but I want to see what it's doing. I would like to know what voltage it's doing. So that's our plan, man. Let me get some resistors and we'll start in on those. All right, so our first one we're taking out is kind of one of the very first resistors in the string. Power comes in right here, jumps up, and even before it gets to the filter caps or the selenium rectifier, it runs through a 22 ohm resistor that was measuring 60 or 61. And that's this one. 22 ohm, you can see by the markings. And believe it or not, about, I don't know, 3 or 4 months ago, I had somebody mail me a ton of resistors. Like, they called them passives, which is a good way to put it, because it wasn't just resistors. But they mailed me a ton of old resistors, and I told them at the time, yeah, I'm going to get all kinds of use out of this. So it has begun. So this is a 20 ohm resistor that measures about 21 ohms. So it's close enough, right? Check that out. It's the same size and everything. It's amazing. Look at that. What a perfect little replacement. I guess it's slightly smaller, but it's still 1 ohm. I mean, 1 watt. Don't worry about it, people. It's going to be fine. So actually, even you're not even going to be able to tell, except for how I J-hooked it, that's been replaced. First one down, on to the next one. All right, so I'm just working through. This one we'll have to talk about here in a minute. This R1, I found it. Instead of 190, it's 184. That's fine. R4, instead of 470K, it's 491K, which is like 5%, I think. So, if they're within like 20%, I'm not really that concerned about them. This is a, what do they call those things? I can't remember the little French name for them. There's a little setup here with a bunch of stuff in one. It's not really a French name. I was just calling it a French name. It's this thing. So it's like an integrated circuit, actually. I'm not going to mess with that. I'm just going to leave it how it is. All right, and I had an issue where these two were both measuring 693,000 in circuit. And I was remarking on the previous video that this one should never be higher than 470K, even in circuit. You can test stuff in circuit, and sometimes it will falsely tell you that something's shorted because something else in the circuit is shorted. So for instance, on this one, so this one is supposed to be a 4.7 meg, but it was actually telling me that it was 693K, which is exactly what this one was telling me. So there was something about the way this is wired in the circuit. Now, remember, the tubes aren't in it. There was something about the way this was wired in the circuit where they were both giving me the same value. So what I did was I cut both of them loose from right here. And when I did that, my one that was 473K still measures 470K, still measures 693K. So it's bad. It's just too far out of spec. It's like, 50% off. That's not good. And my one that's 4.7 meg out of circuit, which it wasn't completely out of circuit, but one leg was off. So if one leg's removed, you can go ahead and test it because the circuit design can't be really giving it trouble. Now measures 4.27 meg, which is about 10% off. So I'm cool with that. I think I got that right. Yeah, that's like 10% off. So that's no big deal. So I put it back in circuit. So I got to find a 470K. Now, there are a few exceptions. Sometimes if you have a big cap around it, like if there's a huge cap right here, what's going to happen is when you try to measure something, your meter is going to start charging the cap up. And so your meter is just going to give you weird readings on a digital meter. Now, on an analog meter or an old school vacuum tube voltmeter, it may work fine like that. I don't know. But anyway, all that to say, we've got a problem here where our 470K is 693. And we've got another one here where our 470K is 550K. So I need at least two of those. I think that was all that I had found previously. So I've got two 470s that I need to find in my parts list here. And I'm going to look at R2 and R3 and make sure they're supposed to be half watt. I want you to look at these beauties that I got sent. I didn't realize I had this set earlier. I may have an exact 22. I put that 20 in instead of 22, but we won't worry about it. But look at this. Tons of them. So I'm fortunate to have that. I need to find a better way to store them, though. I don't really like this setup. So I've got some of those little tray things. I might take some of these out and put them in that so I can get rid of some of these. I hate to get rid of somebody's, you know, obviously somebody had these for years and years and years in these trays. But this just isn't the best storage solution for me. I'm going to leave them like this for a little while, but I'd like to put them in something that works a little better for my storage system. All right, after all that, I didn't have one. I didn't have a small one. I had one that was like a 1 watt, but it was supposed to be half watt, so I just went with the newer one. You can use, of course, a 1 watt when you need a half watt, but I didn't want to waste it. You know, I might need it down the road for something bigger. And I got these nice, beautiful new ones. And, you know, the caps are already new anyway, so what's it matter, really? So I got it in there, and after I did that, the other one actually tested fine. The 550, it quieted down. Now, it wasn't crazy out of spec anyway. That's only 20%, but now it's like 471K. So something about some of the other stuff I had going on was giving me problems, but now that's rectified. Pun intended. Also, I'll be happy to let you know, I remembered what the thing is called, this thing. It's supposed to be called a couplet, but I call it a couplet, the French version. And the reason I do that is because I've noticed that the radio, the radio community gets very upset if you do anything the way they wouldn't do it. Slightly different than the way they do it, they get so upset, some of them. So I figured I'd call it a couplet just to mess with them. So that's a couplet. And if it happens to be bad, you can replace it with discrete components, but hopefully it'll be fine. All right, so I got that one in there. And now we're on to these 220s, which are a mess. They're all over the place. So this one's 281. That's a little bit off. This one's 474. That ain't right. This one's 287. That ain't right. This one's 352. That ain't right. There were a couple of them that were all right, but so I need several 220 ohm resistors, all half watt. All right, folks, so I went through and replaced several of them. I made a list here of all the ones that I replaced. R17, 3, 13, 14, 15, 11, 5, 20, 26. All of those were at least, you know, like I said, more than 20% out. Most of them were 50% out. And I went through and I checked all the other ones, and all of the other ones are within 20%. So we are good. I think that's about as good as I can get it on the resistors. Now, this thing didn't even come with tubes. And it's AM, FM. So I think what the next thing I'm going to do is, and just for giggles. Oh, and we need to talk about this one. So this is an 820 ohm, but it's 1055. That's a little high, but the problem is it's a 5 watt, and I don't have one that big. So we're going to leave it. And we'll see what happens. So, you know, what that's used for is, so you get your 120 in out of the wall, runs through a resistor, and then it goes through this selenium rectifier, which turns it into DC. And when you turn AC into DC, it bumps up the voltage. So they want you to have 149 volts on the other side of the selenium rectifier. And there is a filter cap there. And so then that goes up and it goes to the output transformer. And so you have 149 volts right here. Well, this transformer is just a coil, right? So coming out of one side of the transformer, they're saying that this should be 127. Okay, and over here, it goes to that resistor. Once it runs through that resistor and hits the other filter cap, they're saying that it should be 108. And you know, you need a difference in this voltage here. I don't know completely how it works, but these voltages can't all be the same, or the tube doesn't work. You know, you don't get electrons traveling or whatever happens, right? So it's got to be a different voltage, that's how they bias it, or I guess. And you can look on the schematic or the data sheet of the tube, and it tells you exactly what it likes. But anyway, that's the whole idea behind it. So it kind of depends on what voltage you end up with here, you know. We're going to replace this with a diode and a resistor to get it where we want it. And I guess we'll just go from there and see, you know. This voltage right here is the most important one, I think, because it goes to more than the one tube. So this voltage up here, you're probably going to have the same difference, if that makes sense. Like, this one's going to be higher than this one, even if these are completely the wrong voltage. So if this one's 150, and this, I wouldn't really want it to be that high, but if that one's 150, and this one's 125 or whatever, you got the same thing going on. So anyway, but this voltage here, this B plus voltage is 108, and you're going to see it go to several different tubes. You know, so that voltage is the one that you kind of want to be somewhere near what it's meant to be. With all that said, these damn radios will run way off. I mean, I've had them where we bring them up, and when I get it up to 50 volts, the thing starts working. At 50 freaking volts, it's picking up and amplifying radio signals. So they will work way the hell out of spec. Even replacing all these resistors, I'm just doing it because I'm trying to get it as nice as I can, but you can get away with not even replacing most of the resistors. The thing's going to work even if it's close, like even if it's 40% out of spec on everything. But will it work to the level that you want it to work? You know, will it be something that you enjoy listening to? Will it be something that tunes in good? Will it be something that you're happy with? Maybe not. So if you can get it back to as close to original as possible, theoretically, once you align it, it should work pretty good, right? I would, this one, it's a cheaper set. It doesn't even have a pilot light. It's really plain. This one's real dirty. We're gonna try to clean it up. And the logo's broke. So this is not a high-end set, but it's pretty complex, and it's a 7-tuber. So it probably performed pretty decent originally. All right, so I think I'm going to just try to bring her up with the selenium rectifier in it, just so we can measure it and see what's going on, because that's interesting to me. I know some of you are going to have an absolute conniption fit about that. Oh, you're not going to like it at all. But if you look, this thing doesn't need any tubes to give you that voltage. And the output transformer, it's getting its voltage anyway, right? So, I mean, you're not really hurting it by just giving it the voltage without giving it a signal. I think it's fine. So we're going to test it like that. And I'm going to bring it up on the variac, and I'm going to bring it up on the amp meter slow so that we can see if anything's shorting or anything. And we can measure that voltage really easily from the top of the chassis. So we're just going to take it easy and go real slow with it. And, just see what we get. So I'm going to bring her up, and we want to see what voltage we have there. And then we're going to try to tune it by putting a diode and a resistor in. If that voltage comes up and it's similar to that, we're going to go ahead and bring it up with all the tubes in it, get it to work, and then replace it. Okay. If it's not working where we can't get anywhere near that, I was saying in the previous video, I think when they go bad, they go up. I think it's actually the other way around. I think when these go bad, they go down, so we won't be able to get our 149 volts. And also, whenever they burn up, they stink to high heaven, from what I understand. But, you know, that's another thing. I hear people complaining about how stuff stinks all the time. And, you know, I grew up going to the flea market and going out in the woods, and there's dead animals and stuff. I mean, I'm kind of used to things stinking. So the jury is out on if that's people just whining and complaining, or if it really does smell so bad that you want to kill yourself. So I think we're ready to at least try to bring it up and see if it starts shorting. If it starts shorting, then we'll have to figure out what we screwed up. But to the best of my ability, I think I've got it right. All right, so I have no clue if this is even going to work like this, but you've probably seen me do this before if you watch the channel. I've got the AC running into a Variac. It has a fuse on it. I think it's a 2-amp fuse. The power is coming out of the Variac, and it's running into an amp meter, which is set on the low gauge, which is this bottom one, 0 to 1 amp. Okay. Power is running out of it into the radio. But I don't have that cord, so I just got it kind of loosely connected with the battery holding it down. Look, folks, it's going to be fine. I don't know why you're worried. Okay? And now, really, there's not much getting power, even if the thing works, because there's no tubes, so there's nothing for it to do. Yeah, you got some resistors and stuff, I guess. But even if we power this whole thing up, there's no tubes to do anything. You got some capacitors, I guess, that'll charge up. So I don't know that it will even move. I don't even know that it'll even use any amperage. So what I'm going to do is I'm going to turn it on, and then we're going to watch and see if that needle moves at all. We're at 0 volts right now. So I guess we're on. And I've got the volume all the way up. Of course, there won't be any volume because there's no tubes in it. Right? I'm just trying to get it turned on to where we can check the voltage at the selenium rectifier. I guess I didn't show it. Ooh, it's a nasty looking little thing. Look at it. Have you ever seen something so ugly? Okay. So we'll turn up the Variac, and we'll see we're getting nothing. So who knows if this is even working. Let's see if we can test it. What do you think about that? I guess we'll try DC on the rectifier. There's not even a pilot light. This is a tricky one, folks. Ground. I know this is driving some of y'all crazy. Look, folks, you gotta have a little fun with it. I'm trying not to electro kill myself. We got 67 volts DC coming out of the selenium rectifier. My Variac is at 50 volts. All right, we're going up a little bit. I guess we need to watch the ammeter. So the whole idea is, if there is a short, what's going to happen is the two, you're basically, your voltage is going to short to ground or something. If there is a short, that you're going to start getting amps running through that, and we're not. So that tells you that there's probably not a short, at least in the part that we were able to test. Okay. So now we're up to 80 volts AC going in. We're at 101 volts coming out. So when they explode, is it going to get acid all over me or something? All right, 100 volts. Of course, it's not shorting, or doesn't seem to be shorting. 137 volts coming out. All right. So that is 110, but I believe I've tested that before. Let's do it live. Let's do it live. I believe I've tested that before, and 110 is actually about 120. All right, so the Variac is set at 113 or so, but it's actually measuring 124. And, you know, that's pretty similar to what my wall voltage is here. The wall here is 124, 126, something like that. So that's about where the thing would operate if we had it just plugged into the wall. And let's see what we're getting out of the selenium rectifier. $152.6. So it's dead on the money, really. I mean, it might go down once we get a load on it, maybe. So it's 149, but that's at 115. $117. Line voltage set at 117 volt AC. Voltage should be, as shown, plus or minus 20%. Okay, so I mean, it's dead on the money. Now, I understand that things blow up and they screw up, so we're going to replace it, but I think a lot of that, I think some of that's overstated. Yeah, the thing will probably burn up if we leave it on long enough, but it's still working, and it's still kind of right where it's supposed to be. Our voltage is a little high going in, and it's a little high coming out of the rectifier. And keep in mind too, well, you may have not saw it on the, I don't know if I mentioned it at the beginning of this video. Instead of a 60 and an 80, I put 200s in. Wouldn't that raise it a little bit? I think they were both supposed to be 80s, but on the can it actually said 60 and 80. Okay, yeah, 80 and 60. Yep, that's correct. But I put 100 and 100, so that's probably going to bump it up a little bit. So, you know, seems cool. But we need to get tubes, and we need to align it and all of that. And, of course, it needs a ton of cosmetic stuff. And all we know so far is that we're getting voltage up to and out of the selenium rectifier. The speaker could be bad, the output transformer could be bad, there could be all kinds of stuff.
Ladies and gentlemen, dust-covered circuits sitting on a desk, been lost in time, 50 years of rest, reading schematics and thrifting old parts. One more last week. Old board, new sparks, tracing faded traces, vacuum tube blows, get it back to working by the end of the show. Bringing broken gadgets back to life, turning silence into stories, one at a time. We fixing to fix them, easy as can be, amateur repair time for you and me. Little machine, you carried history, time to trace your path, bring your mystery. From open to singing, learn, preserve, repeat. Cable sneak. capacitors, rummaging